Hi everyone, welcome to Code Guy channel. This is video about how to implement Bisection method. And I want to be honest with you, this part makes me irritated. I hope you will be appreciative of my struggling. Let's get started. Bisection method is also known as a binary search method. Here in the description for this lab is not enough theory to understand what to do. So you definitely need to search to find out what is the bisection method is. The key sentence is the number 2. It works by narrowing down an interval where the square root lies until its coverage to a value within a specific tolerance. First of all, let's talk about what is a square root. 5 multiplying by 5 will give us 25. Getting a square root from number, it is moving in opposite direction. So square root of 25, it's 5. Every square root must be somewhere in between two numbers. It couldn't be less than 0 and more than square root value. In our case, it will be number between 0 and 25. So what we need to do here, we need to figure out what is our interval from low number to highest number and keep dividing it by half until we didn't find out what is the value what we are looking for. We also have a tolerance number. It's basically the point where we have to stop dividing our intervals. If the difference between high and low number will be less or equal this tolerance, then we found the answer. If you didn't get it yet, don't worry, you will see the solution and you will figure it out. As the first step, let's define the function. Square root bisection function that takes 3 parameters. A number of which you want to find the square root. The tolerance. Tolerance can be whatever you want to, but I choose the value from an example, 0.01 as a default value, and the maximum number of iteration we wanna perform. I chose 100 because it is a maximum I see in our tests below. I will run the tests to show you that everything is working well. Okay, the first thing we need to do is the make each case. If we are passing a negative number, we need to erase a value error. Square root of negative number is not defined in real numbers. As you may know from math, the square root cannot be negative. Let's write the if statement. If number is less than 0, raise value error and the error message. Square root of 0 or square root of 1 will be a number itself. 0 multiplying by 0 is 0 and 1 multiplying by 1 is 1. Let's add another if statement. If number equals 0 or number equals 1, print the square root of number is number. Return number. So far so good. Tests from 1 to 7 are passed. What if we want to know the square root of number that less than 1? Let's say we have a number 0.25. Square root of 0.25 will be 0.5. 0.5 it's smaller than 1 and our answer will be outside of the interval of 0 and 0.25. This way we are defining two variables. First variable is a low that will be equal to 0 and the high that will be maximum between two numbers, 1 and number. So if we need to count square root from 0.25, we will go up and will be capable eventually to come to 0.5. Okay, now we need to create the for loop to divide our interval by halves until we reach the tolerance number. For underscore in range of max iterations. Why underscore? Because we don't use this variable anywhere. It's a syntax convention for this type of cases. Range max iterations because we don't have to go out of the amount of iterations that we are passing inside our function. Every time we will define the middle value, we will define the mid variable that is equal to low plus high dividing by 2. We need this variable to split our interval by 2 equal parts. Now we need to create if statement. If high minus low less or equal tolerance. It means that we reached our restrictions and we have to stop iterating. Here we will print the square root of number is approximately mid. The mid again, it is a center our constantly dividing interval. Then we add another if statement. If mid multiplying by mid is less than number, then low equals mid, else high equals mid. Mid multiplying by mid, it's a square value for the mid, and number it's also square root. So we're comparing two square roots. If square root of mid is less than number, then our guess is too small, and we are moving on the right. Low equals mid. If it is more, then we are moving on the left. High equals mid. In the end of our function outside of the for loop, we need to print the message failed to converge with a max iterations and return none. So basically, if we cannot count our mid value in our for loop, then we return in the message that we failed to do it. That's it, we're finished with our algorithm. All the source code will be in my GitHub repository. Thank you for watching, bye bye.